Today, when we're doing division, we're not going to be dealing with radical signs or symbols. What we'll be dealing with are rational exponents. So if you recall, rational means fraction, and we have an exponent that's a fraction, it really means that expression could have been written as a root, a radical. So that's why this topic fits nicely in our module. So let's recall our rules. If I had a to the fifth divided by a squared, okay, simple polynomial expression. We know the rule for division is when you divide variables, you subtract exponents. So you would get a to the fifth divided by a squared would give us a cubed. That rule holds true regardless of what kind of exponent you have. And we've discussed this already. We've seen exponents that are positive whole numbers, which is what we like because that's what we understand. We understand a to the fifth means a times a times a times a times a. But we've also seen in this course exponents that are negative whole numbers, integers, and we've learned how to fix that. We've learned how to make a negative exponent positive. We've also seen in this course how exponents do not have to be just whole numbers. They can be fractions. Even if the exponents are fractions, the rule doesn't change. If you're dividing variables, the rule is to subtract the exponents. So if you look at my next example in the PowerPoint, I have a to the 3/4 divided by a to the 1/4. Now, it's important you understand I'm not asking you to divide 3/4 by 1/4. If I wanted you to divide 3/4 by 1/4, then my statement would have said 3/4 divided by 1/4. I'm asking you here to divide the letter a. And the rule is the rule is the rule. When we divide variables, we subtract the exponents. Whoopee-doo that the exponents are fractions. We know how to subtract fractions. We need a common denominator. Well, 3/4 and 1/4 do have a common denominator of 4. So all we do is adding and subtracting fractions. We talked about this. Adding fractions easy as can be. All you need is an LCD. Write the bottom, collect the top, reduce the fraction, then you stop. So when we divide a to the 3/4 by a to the 1/4, we write our base a. We say 3/4 minus 1/4 would be 2/4. 2/4 can be reduced. There's a greatest common factor of 2, and 2/4 will reduce to 1/2. So now our answer is a to the 1/2. And that's great if you're told to leave the answer with a rational exponent. So if your direction said, leave my answer as a rational exponent, you would write a to the 1/2. But what happens if your direction said, write my answers in radical form? Radical means to write it with a root symbol. Well, we have to remember our definition. When you have a fraction that's an exponent, the numerator of the exponent is still the exponent, the power, but the denominator of the exponent is the root. And if that denominator is a 2, that meant this is a square root. And it's square root of a to the first, which we would write square root of a. So in algebra, you writing a to the 1/2 and somebody else writing square root of a are equivalent statements. They mean the same thing. So make sure you read your directions and know what form they want the answer in. Now, there's another way to work that expression. You could have first, instead of doing the subtracting of the exponents, you could have first rewritten both the numerator and denominator in radical form. So if you look at your notes, again, I took a to the 3/4, and now this time, instead of doing division, I'm going to rewrite that. That really means the 4th root of a cubed. And in the denominator, instead of having a to the 1/4, that means the 4th root of a. And we've already talked about division of roots. To divide radicals, expressions, you divide the coefficients in front. Well, we don't have any. They're understood to be 1. And you divide the radicands. So the radicands are a cubed divided by a, which would be a squared. So now you have the 4th root of a squared, which we cannot simplify because the 4th root means I need 4 terms inside. A squared means I only have 2 terms. A squared is a and a. But I can rewrite the 4th root of a squared as a rational exponent, as a to the 2/4. The 2 is the exponent. It goes in the numerator. The 4 is the root. It goes in the denominator. And once I write a to the 2/4, that reduces to a to the 1/2, which means the square root of a. Now you tell me, again, which method was quicker? Was it quicker to leave the exponents as fractions and subtract them? Or was it quicker to change the exponents that were fractions into roots and do the division? And if you agree with me, it's easy to work with the exponents that are fractions. So don't be afraid of them. Okay, we're going to practice some more expressions on the whiteboard.